whole bunch of shaded region. Okay? So when you're doing these things, treat these things just like you guys did with regular systems. Cover and solve. Get your intercepts. Get your ordered pairs for those. And then shade accordingly. Okay? Now, we've shaded these before, but we only did one on a graph. Here you've got 3 or 4 of them on a graph. You have to figure out your spacing. Okay? And that's kind of what takes time to realize how it works, is how you space things out and pace things through. Okay? I thought, did we set up 45? Thought we did that one there or somewhere in that neighborhood, but let's just kind of pick through here. We'll look at 46. Excuse me. Now, with these things, like I was saying, I'm trying to steer clear of using graph paper. I want to make sure that we start to see how these things get placed, how you can put out your intercepts and things like that. One of the things that I've helped people with throughout working on these things is to try and identify within your systems right away where's going to be your largest intercept. What value is going to give you the biggest number for your intercept? And I would place that first and scale everything off of that. In this example here, you'll notice the largest intercept I'm going to get is going to be at 2. Do you see that? Because if I get the y-intercept on that one, it would be at -0.5. So when I place it, if I space this out nicely, I'll put a 2 here. Okay? If that's 2, that would be a 1. See how I'm just making my own scale. Okay? I think there's one that we did there was a 10, and then the other intercept was at a 1. So I placed it, oops, the way I was counting that one is if I put 10 here, this would be 5. This would be about 2.5. Here's about 1 then. I'm just scaling it through that way. Just visually, I'm not counting anything, I'm not putting tick marks. I'm just saying, here's 1. All right. So here I'm doing the middle equation. Excuse me. So I've got it at 2, and then the other one would be at -0.5. You okay with that? So here's the other one. So here's 2, 0, 0, -0.5. Now, plotting zeros, that's pretty simple. From there is the first thing you have to make your decision on. Does this one have to be connected via dots or solid? Dots. I'm on the second one, yeah, because what I'm doing, I don't do always in order, so you have to just remember which one you're working on. I'm working on this one. So this one's going to be your dotted. Okay. Did it go through the origin? It came close, but it didn't go through it. So I use that 0, 0 as the test point. So what's 0 minus 0? Is that smaller than 2? Yes. So I'm shading towards the origin. Okay. Y is greater than or equal to 0. When y equals a number, remember it's always a horizontal line. In this case, it goes through the origin. Now, which way is y bigger than 0? Above the 0 line or below the 0 line? Above. Okay. So I know I'm going that way. Then lastly is the y is less than x. Well, y is less than x is the same thing as saying y equals x. So you treat it as a slope-intercept form like mx plus b, where your slope is 1 and your intercept is at 0. Okay? Now I know I'm at 0, 0. Then I would be at -1, -1. I'd be at 1, 1. I'd be up at 2, 2. Just because the way the slope works. Following your scaling of where you put your points, if you will, you can kind of fill in the blanks then. This one between those 3 would be solid because it's got the line. Now this one went through the origin, so I don't use it. I use any other point that I want that didn't go through the origin. Yes, sir? Oh, I'm sorry, I looked at yeah. Sorry, thank you. I was looking at the top one, and we did that just a second ago. So here's what happens. I used a pen. Now it's fixed. Anytime you do that, if you don't want to go back and erase it or anything like that, just label it and say, oh, it's dotted. And then we know that it's okay. But thank you guys, I missed that one. And then, like I said, we just got to go back and look at an ordered pair. Well, we already have an ordered pair labeled right there, 2, 0. But here's the kicker on this one. If you're going to use this to test here, 2 is your x, 0 is your y. A lot of times people accidentally flip it in there and do the wrong graph, wrong shape. So your y value is 2, your x value is 2. I'm sorry, y value is 0, x value is 2. I thought I said that. Is that true or false? That is true. So it's from this line here, it's true coming this way. So this one gives you this shaded region in here. Okay? That's how this stuff should start to look. Yes, ma'am.
You're allowed to make a factor.
Third equation, this one?
Yeah.
Okay. Do you agree that that's the same thing as saying y equals x?
Yeah.
Okay. Give me any value for y. So what would x have to be? If y equals x, then you have 1. Yeah. Think of it this way. This is the same equation as y equals 1x plus 0. Y-intercept at 0, slope of 1. That's what we go up 1 over. That's where that came from. Okay. All right. Let's see. You want to do 48 or you want to do 47 next? 47? Now, guys, as you get into these, there's a vertical line and there's two with slopes. Okay? There's a vertical line and there are two with slopes. Do the easy one first, the vertical line. Yes, ma'am.
Will these kind of questions
Sure. Absolutely. Excellent. And will they be up this type of stuff on a test or yes? X is less than or equal to 2. Very good. It's moving back. Less than or equal to 2. Now the other one I'm going to write them. It's for the most part. A lot of times it's easier for us to write equations in slope-intercept form instead of trying to figure out what it is in standard form. Even though graphing standard form is easier, writing in slope-intercept isn't so bad. So if I go to the first line here, positive slope. Everybody okay with that? Yeah. Could you kind of walk it if you had to? Let's see. Oh, that doesn't look all that clean, does it? Wait, here we have 1 here, up 2 over 3, up 2. So I'd say 2/3 for the best point value. I promise on any test or quiz or stuff like this, I will make sure that I will darken an ordered pair so you will be able to see specifically where things are going through, so that we don't have to try to guesstimate. But I'd say I have a positive slope, 2/3 x. What was the y-intercept then? At 3. Tricky part. How do we know is it less than or greater than? Okay. So what we want to do is, this line didn't go through the origin, did it? Well, I want to shade towards the origin, so I got to make sure that it's true. So I throw in 0 for both x and y. Is 0 and 3. I want this to be a true statement, so what would have to be then? Very good. Has to be less than or equal to. I'm using it because it doesn't go through the origin. So I know that I'm going to substitute in 0 for both x and y. We can write equations all day long, but we want to see, well, is 0, if I put 0 into this, so what's the relationship that it has to be true to shade the truth? It's got to be a less than or equal to. Okay. Then I do the same thing with the last equation, or inequality, excuse me. That one I believe has looks like a slope of -1. Does that look right? So in terms of, but it went through the origin, so it's just going to be y equals a negative x. So again, I need to figure out some place that it's shading above, so it's shading this spot here, this point here, isn't it? So use this point to determine your test point. So this one's at what, 2 and 0? So if I use 2, 0, I want this to be a true statement. What would it have to be? It would be a positive 2, but it's -1 times that. So that's why you throw that up in front of it. So what would that have to be to make that a true statement? Yeah, and this would have to be greater than or equal to, because this is still a solid line. That's what you're looking at as you're trying to build these things on your own. Okay? That's what you're trying to do on your own on those. And then lastly, that looks like the same one, just Here. Take a picture of those four. If you haven't finished any of those book ones, you got to look through any of those others. Make sure you get through. But let's add these four to it. Just scratching four more of them. Then tomorrow I got a whole bunch of other. We'll go back and review systems and solving and all that. Because then we will quiz over all the graphing and system stuff Wednesday. And then Thursday on the half day we'll start building constraints, which is still kind of similar to this, but then we're going to find a lot more of the ordered pairs of intercepts as we go on. We'll do that. We might start the word problems on Friday. Probably not. We'll play it by ear and go from there. Yeah. Did that help going over all those again?
Yeah, I think so.
I hope so. And then I'll print this PDF later on. As well as last minute. Let's do these problems type thing.